Now we come to the probable and proved or proven energy reserves. It's important to remember that both types are estimates and that as time has gone by, these estimates have become more sophisticated. In addition, both types are recoverable under existing economic conditions as well as operating conditions. This basically means that the market will support the extraction of these energy reserves, as well as the technology will be enabling the extraction of these reserves. The difference between the two is that probable reserves are where the location, quality, and grade of the energy reserves are not well established. And right now, for example, the world probable oil reserves, everybody wants to know about oil, is about 565 billion barrels. Notice 565 billion barrels. That is an enormous number, but again, that number is a probable reserve number. If we contrast that with the proved reserves are where the location, quality, and grade is well established. Notice how that number changes dramatically. Today's world proved oil reserves are 1,431 billion barrels. So we have a very big difference between the probable reserves and the proved reserves. Finally, we come to the misleading reserves to production ratio. This ratio is a tool that simply divides the world's proved reserves by the world's annual production. It can also be applied to countries or states, but typically it's applied to the world. And it's used oftentimes to provide a quick snapshot of the number of years that are remaining before a resource runs out. I use the term runs out carefully because there's a lot of problems associated with that term. What does in fact runs out mean? Does it mean that, say, an oil well is literally dry, which doesn't ever happen, or does it mean that it's simply too expensive for an oil company to extract the oil from that well, given market conditions? So that in and of itself is a problem. The most typical example where the reserves to production ratio is applied is with petroleum. So right now in the world, we have the world proven reserves of 1,431 billion barrels. That's the R in the reserves to production ratio. And annually, the world consumes about 25 billion barrels. That's the P in the reserves to production ratio. So the division problem is very simple, very straightforward. You simply divide the R, which is 1,431, by the P, which is 25, and you get a shocking 57 years of petroleum left. Now, nobody actually thinks that the world's going to run out of oil in 57 years. The problem with this is that the ratio is too blunt. It's an imprecise tool, and it's really inappropriate for judging long-term resource availability. There are three big reasons for this. The first reason is that companies are always seeking additional energy projects. They don't want to wake up one morning and find out that, wow, they don't have any more energy resources to extract. They're constantly searching for new fields. In addition, every year that goes by, resource extraction technology improves. This is best exemplified in the United States with the rise of hydraulic fracturing and also horizontal drilling. These two means of resource extraction, both for natural gas and petroleum, were not used together to any degree anytime in the 20th century. And now, in the United States, they're used all the time. And this has dramatically changed our natural gas and our petroleum projections in the United States. Finally, while the reserve to production ratio considers the consumption habits of consumers, it simply considers how much we're consuming. It doesn't consider any changes, and it doesn't consider any efficiencies. So consumers, while we tend to consume ever greater quantities of energy resources every single year, it doesn't. The reserves to production ratio doesn't consider things like changes in efficiencies, say with our cars or with our homes, or with energy policy that can persuade or even sometimes mandate efficiencies. And in that case, we have then these three big reasons why, if it was me, I would leave the reserves to production ratio on the shelf if I was trying to determine or model future resource availability. It's simply too blunt and too imprecise. It makes for juicy headlines, but it's at its core just simply too inaccurate to be any real use in our course or in our discussions.